Good morning, one and all. Myself, Professor R.S. Kognole from TSSM Bivrabai 7th College of Engineering, Nare, Pune. Today, I will be discussing about flow through pipes, that is, energy loss in the pipe flow. Pipe is a closed conduit through which the fluid flows under pressure. Fluid flowing in a pipe is always subjected to resistance due to shear force between fluid particles and surface of the pipe. Pipe flow may be laminar or turbulent depending on the value of Reynolds number. If the value of Reynolds number is less than 2000, then we can say the flow is laminar. If it is between 2000 to 4000, the flow is transitional flow. And if the value of Reynolds number exceeds 4000, then the flow is called as turbulent flow. Energy losses in the pipe flow. When the fluid flows through the pipe, there are two types of losses which are occurring. One is the major loss and another is the minor loss. Now, this is the schematic diagram of the losses occurring in the pipe. So, losses in the pipe are major losses and minor losses. Major loss is due to friction loss and minor losses are due to loss due to entry, loss due to exit, sudden contraction in the pipe or sudden expansion in the pipe, if at all any obstruction occurred in the pipe, or any fittings provided in the pipe like T-section, bend, elbows, etc. Let us understand what is energy loss, that is the major loss. Major loss is due to friction, as we discussed. This frictional loss was given by Darcy-Weisbach. The loss due to friction is much more in the case of long pipes as compared to the short pipes. This can be classified, or this depends on the roughness of the pipe, length of the pipe, velocity of the pipe, the diameter of the pipe, material of the pipe. So these are the factors which are responsible for the major loss. Now, major loss is given by Darcy-Weisbach equation. The equation is HF is equal to FL V square divided by 2GD, where HF is the loss, head loss, F is the Darcy-Weisbach friction factor, D is the diameter of the pipe, L is the length of the pipe, V is the velocity flowing through the velocity of the flow, and G is the gravitational acceleration. Next is the minor loss. Minor loss in the pipe is due to the pressure loss in the pipe due to various fittings, components, valves attached to it. As we discussed, the loss is due to entry, exit, sudden expansion, sudden contraction, or due to different fittings which are different fittings like elbow, T-section. So let us discuss each loss. Head loss due to sudden contraction is given by equation HE is equal to V square by 2G in bracket 1 upon Cc minus 1 square. So where V is the velocity of the second pipe or velocity of the contracted pipe, G is the gravitational acceleration, and Cc is the coefficient of acceleration. If Cc is not known, then we consider the equation as 0.5 V square by 2G. Next loss is due to sudden expansion. There is a sudden expansion in the pipe, and due to which the losses can be created, and the equation given for it is HE is equal to V2 minus V1 square divided by 2G. V2 is the velocity in the bigger pipe and V1 is the velocity in a small diameter pipe, and G is the gravitational acceleration. Next is loss due to obstruction in the pipe, and it is given by the equation V square by 2G in bracket A divided by Cc A minus small a minus 1 square. So here in this equation, A is the area of the pipe Small a is the area of the obstruction which is in the pipe, and v is the velocity of the flow, g is the gravitational acceleration. Next is due to any fittings, as we said. The fittings provided may be elbow, maybe a T-section, or a simple bend provided to a pipe. Now in this case, the generalized equation which we have is HE is equal to K V square by 2G. K is the coefficient of this fitting. So depending on what type of fitting we have, the K value is considered. Usually K is taken as 0.5. Likewise, we have two other losses, that is loss due to entry and loss due to exit. At loss due to entry, we have the equation as HE is equal to 0.5 V square by 2G, and loss due to exit, we have the equation as HE is equal to V square by 2G, V square by 2G, only V square by 2G, where K is equal to 1. I hope you have understood what are the losses in the pipe flow. Thank you.